2 a.m. Priya's phone lights up. Pager duty. Nightly pipeline failed. Dashboards empty by 8 a.m. She opens the laptop. One monolithic script, 400 lines. One stored procedure on one server that only Marcus understands. And Marcus is on vacation. This is the world the modern data stack was built to end. 3 tools. 1 pattern. Everything about how data engineering works today came out of solving this exact night. 2010. This is how every mid-sized company's data pipeline actually ran. Marcus, the senior data engineer, owned it all. One SSIS package, or one 400-line stored procedure, ran on a Windows server under his desk, scheduled through Windows Task Scheduler. Logged to a text file nobody looked at, unless it broke. Marcus was the only person who knew what it did. It worked, until Marcus took a vacation. Then the whole company waited for him to come back. 3 pressures the monolith could not absorb. First, data volume went from gigabytes to terabytes to petabytes. The single server ran out of RAM, CPU, and disk. Second, change requests queued for weeks. Every new report meant a schema change, a test cycle, a deploy. Product moved in days. The pipeline moved in months. Third, the team could not scale. New hires took 6 months to touch it. Nobody wrote tests. Data engineering became the bottleneck of every roadmap. 2015. One thing changed and rewrote every pattern that followed. The cloud data warehouse arrived. Snowflake, BigQuery, Redshift. Compute you could summon with an API call. Storage that scaled to petabytes without ops work. Suddenly, the answer to how do we process this changed. Old model. ETL server does the work. Warehouse just stores results. New model. Push raw data in. Warehouse does the work. Warehouse is the compute. That inversion invited 2 new tools to fill the space around it. Piece 1, the orchestrator. Something has to say what runs when and what depends on what. Airflow or Dagster or Prefect. A directed graph of tasks. It declares what runs, when, and in what order. Retries on failure. Alerts on breakage. Backfills on demand. Marcus's task scheduler on a Windows box became a Git-tracked pipeline the whole team could read. Piece 2, DBT, the move that reshaped analytics engineering. Before DBT, SQL lived in Python scripts, or stored procedures, or Tableau workbooks. No tests, no lineage, no version control. After DBT, SQL lives in Git. Every model is a .SQL file. Tests declared in YAML. Lineage graph generated automatically. Pull requests, reviews. DBT did not invent SQL. It gave SQL software engineering, and it pushed the transform into the warehouse next to the data. This is what turned data engineer into analytics engineer. Piece 3, the warehouse itself. Snowflake, BigQuery, Redshift, Databricks. What they all share matters more than what makes them different. Separation of storage and compute, elastic scale up in seconds, pay for what you run, standard SQL, so DBT can target any of them. The vendors are interchangeable. The abstraction is not. Why did this trio win over every all-in-one alternative? One reason, each vendor owns exactly one job. Orchestrator answers when. Transformer answers what. Warehouse answers where. 3 boundaries, 3 specialists. If any one piece gets slow or expensive or stale, you swap just that piece. No replatform, no lock-in. That is why the pattern has outlasted every vendor pitch for a bundled replacement. What the modern data stack quietly killed, without a funeral. First, the all-in-one ETL tool. Informatica, Data Stage, Talendy, displaced by DBT, plus airflow at a fraction of the license cost. Second, the DBA as gatekeeper. Schema changes used to need a ticket. Now they need a pull request. Third, the single hero on call. Marcus's 400-line procedure became 40 tested, Git-tracked models. The 2 a.m. page went to the tests instead of Priya. That night, her pager finally goes quiet. A failing test caught it. She goes back to sleep. The modern data stack is not a product. It is a separation of responsibilities. Orchestrator, transformer, warehouse, 3 tools, 3 jobs, 1 boundary between each. Swap the vendor, keep the shape. But even this pattern has a limit. When 200 engineers all ship into one warehouse, it starts to feel like Marcus's stored procedure again, just distributed. Next on the architecture track, data mesh. When the org itself becomes the architecture,